This is an example of a word problem that involves a quadratic function. In this case, I will not ask you to complete the square on the quadratic function, but instead we'll use our graphing calculator and a method that we've learned before to answer our question. This question says that a rocket is fired upward at some initial distance above the ground. Its height in feet h above the ground, t seconds after it is fired, is given by this function. Find the rocket's maximum height and the time at which it reaches this maximum height. So the first thing you would want to do is go into your y1, and then you would want to enter the function that they've given you. Remember that you have to enter x values instead of t's for this example. Let's think about our window for just a minute before we go and put this in our calculator. The function h of t represents height. We see that the understood y-intercept from this function is 2304. So we know that the y maximum must be at least that value or more. So that will give us a good idea of how big to set our y max. Now, we also know that t represents time in seconds after this particular rocket has been fired. So we know that it could not be negative. So as far as our window, and we can change this later if we need to, let's start our understood x value, which is representing time, with 0, and then let's say for the maximum we go to 20 seconds, and we can change that if we need to. And then the y's, which is representing height, let's try 0, and then we know it's got to be something bigger than 2304. Let's say that we go to 5,000. That may be too big, it may be too small, but we can change that later on. So go to your y equals. If you have a function in there, clear it out. This would be negative 16 x raised to the second, arrow right, plus 160 x plus 2304. Go to the window. Looks like our x minimum be 0. Our x maximum be 20. Leave the x scale alone at 1. The y minimum, let's put 0. The y maximum, let's put 5,000. And then don't do anything with the other two values below. Go and press graph. Okay, this looks like a good window. And so what I want you to do is I'd want you to sketch it. Make sure that you also indicate for me the window that you have used in your sketch. So I would say on the x-axis it's 0 to 20, on the y-axis from 0 to 5,000. Now what we need to do is we need to determine the maximum value for this particular graph. To do that, we would do second, trace, and then pick maximum. Then it will ask for a left bound. We want to arrow to the left of where we think the maximum is going to be. In our graph, we see the maximum is going to be right in this area. So we want to arrow to the left and make sure we're off of that value. Press enter, and then when it asks for a right bound, arrow to the right, make sure you go past the actual value and off of that value. Press enter, and when it asks for a guess, press enter again. And so on here, it looks like my maximum, I'm going to go ahead and round it. It's 4.99999, so we're going to round that to 5, comma, and then 2704. Now looking at what the question is asked, it wants to know what is the maximum height of the rocket. The height was my y value. So the maximum height is going to be 2704. Make sure you put the proper units. It's going to be in feet. Okay. Then it also wanted to know the time at which it reached its maximum height. Okay, so it reaches maximum height at t equals 5 seconds. We want to make sure to put the proper units on that as well.